This is the Math 2 lesson summary video for the lesson entitled, Are Relationships Predictable? In this first lesson on trigonometry, the purpose of the lesson is to use our knowledge of similar triangles to comprehend trigonometric ratios, and then apply this knowledge to find missing side lengths in right triangles. We will learn that the sine of an angle is equal to the opposite side over the hypotenuse in the right triangle. The cosine of an angle is equal to the adjacent side over the hypotenuse in a right triangle, and the tangent of an angle is equal to the opposite side of the angle divided by the adjacent side of the angle in a right triangle. In Lesson 7, Are Relationships Predictable?, we were asked in our notebook to draw a right triangle with one angle of 60 degrees. We used a protractor in order to determine if our angle measure was indeed 60 degrees. And then we also need to make sure that another angle is 90 degrees in order for this to be a right triangle. What I've done here on the bottom is I have just sketched a right triangle and labeled 60 degrees. In class, we did measure these using a protractor. We were then asked to measure the side lengths. So I'm going to, without measuring, I'm going to put some side lengths on this right triangle. Say that this length is 4, this length is 3, and this length is 5. So we were asked to create the following ratios. So the opposite side is always with regards to the angle of reference. So in this case, our angle of reference would be the 60 degrees. Your angle of reference will not be the 90-degree angle. So if we are looking at the 60-degree angle, we need to figure out what side is opposite the 60-degree angle. And if we look at this right triangle, the 4 units long is the side opposite of the 60 degrees. We want to figure out what side is the hypotenuse. The hypotenuse will always be opposite the right angle. So this side here will be the hypotenuse. And the last side that we have to figure out is the adjacent side. Adjacent means next to. The adjacent side will be the length of 3 in the right triangle I've drawn because it's adjacent or next to the reference angle. So then we were asked to draw or figure out some ratios. The length of the opposite side is 4 over the hypotenuse is 5. The length of the adjacent side over the hypotenuse is 5. And the length of the opposite side over the adjacent side is 4 over 3. So we will be doing this a lot more throughout this investigation. We're going to be writing ratios based on right triangles. So then we were asked to compare our ratios with others in class that had a triangle of a different size. So we did go around and we looked at each team's triangles and each pair of partners. And we did notice that all of these ratios that we came up with when we measured those lengths, as long as one angle was a right angle and one angle was a 60-degree angle, that the ratios ended up being the same when we divided them. And the reason that is because all the triangles are similar by angle-angle similarity. We have a congruent right angle in both of our triangles, and we will have a congruent 60-degree angle in both of our triangles. So then in number 2, we are asked to practice on a triangle that was given to us. So in the triangle on the left, we actually had to find the length of BC. So to find the length of BC, we will use Pythagorean theorem. Once we solve that for x, we will see that the length of BC is the square root of 27. If you recall from our prior unit, we can simplify that radical into the square root of 9 times the square root of 3, which simplifies to 3 root 3. So I know the length of line segment BC should be 3 root 3. Then we are asked to come up with some ratios based on this triangle, and they do give us where our reference angle is. They want our reference angle to be angle A. Angle A is up here. So from angle A, the first thing we should do is label the opposite side, the adjacent, and the hypotenuse. The opposite side of A will be side length BC. The adjacent side to reference angle A will be the length of 3, or AB, and the hypotenuse will be side length AC. Recall that it is opposite the right angle. So now what we're asked to do is write our ratios. the opposite over the hypotenuse would be 3 root 3 over the hypotenuse, which is 6 units. And we can simplify that fraction. 3 goes into 3 once, and 3 goes into 6 twice. So root 3 over 2 would be that ratio. The adjacent side over the hypotenuse should be 3 over 6, which simplifies to 1/2. And the opposite side over the adjacent, opposite side was 3 root 3, and the adjacent was 3. When we simplify that, we get root 3. So these are our ratios that relate the opposite side, the adjacent side, and the hypotenuse in a right triangle. So then we're asked to do that in another triangle, and we notice that we're missing the length of EF, so we'll use our knowledge from Math 1 and use the Pythagorean theorem to find the length. When we solve to get x by itself, we should get x is equal to the square root of 108. And I'm noticing right now that should not be a square right there, so let's just make sure that's an x. That was our value, root 27. When we simplify this radical, we can break that down into root 36 times root 3, which ends up simplifying to 6 root 3. So I know that this side is equivalent to 6 root 3. So now they're saying that our reference angle is angle D, and they're asking us from this reference angle to find the opposite over the hypotenuse. So again, the opposite side of that angle is side length EF. The adjacent side will be side length DE, and the hypotenuse will be side length DF. So the ratio of the opposite side over the hypotenuse will be 6 root 3 over 12, which we can simplify. 6 goes into 6 once, and 6 goes into 12 twice. So root 3 over 2. Notice that our answers for both of these triangles actually simplify to the same ratio. If we move down to the next, adjacent over hypotenuse, we have 6 over 12, which simplifies to 1/2. And again, we see that both of those ratios are equivalent, 1/2 and 1/2. And the opposite side over the adjacent side will simplify to root 3. So in number 3, we were asked to notice what we see regarding these ratios. And we can see that the ratios of the corresponding sides are the same. So what can we infer, or what can we conclude about the angle measures of triangle ABC and triangle DEF? And so if the ratios are the same, what that means is these triangles must be similar. So the measures of the corresponding angles must be congruent. So we then wrote down these ratios. The sine of theta will always equal the opposite side in a right triangle from the reference angle divided by the hypotenuse. The cosine of theta, which is also known as an angle, is equal to the adjacent side in a right triangle over the hypotenuse, and the tangent of theta in a right triangle is always equal to the opposite side over the adjacent side. Notice that we've said these have to be right triangles. We cannot use sine, cosine, and tangent if the triangle is not right. We were also provided with an acronym in order to help us remember these formulas. The acronym is SO, CA, TOA. The SO stands for sine, opposite, over hypotenuse. CA stands for cosine, equals adjacent over hypotenuse, and TOA stands for opposite side over the adjacent side. So if we're given a right triangle and we are given from reference angle, let's say C in this case, and we are given two side lengths. Let's say that this side is 5 and the hypotenuse is 11. And we are asked to find the sine of C, the cosine of C, and the tan of C. The first thing we would need to do is find this missing side length. So we would do Pythagorean theorem, 5 squared plus x squared equals 11 squared. We know that's 25 and 121. We would subtract 25 and x squared would equal. So we would get x squared equals 96 and the square root of both sides. We can simplify 96 into root 16 times root 6, which would be 4 root 6. So I'll leave this length as 4 root 6. So the standard for this lesson is being able to write our ratios. We know from sine, opposite our reference angle C, this is O, this is A, and this is H. So the opposite side is 5 and the hypotenuse is 11. The cosine of C is adjacent over hypotenuse, so that would be 4 root 6 over 11. And the tangent of C will be the opposite side length of 5 over the adjacent 4 root 6. Now we'll talk more about what we need to do when we have a radical in the denominator. We have to perform something called rationalizing the denominator. But for this lesson, the standard is if we can write our ratios for the sine, cosine, and tangent of an angle theta. If you need more help on the Ready, Set, Go homework for this task, please check the Canvas Student Support site.